Today we are uncover the silent threats in the blast furnace operation, water, steam and hydrogen. These are not just chemical curiosities. They are explosive threats hiding in plain sight. Let's dive into the science, the risk and the life-saving strategies every blast furnace team member must know. Water is deceptively innocent, but in molten metal work, it's a hidden enemy. It can trigger deadly steam explosion and release hydrogen gas, both capable of catastrophic damage. Our goal today is simple: equip every blast furnace team member to spot and prevent these dangers before they strike. Let's break down the science. Steam explosion happens when water vaporizes instantly, expanding 1700 times at blast furnace temperature. Hydrogen explosion are chemical. Molten iron react with water, releasing hydrogen gas. That's Fe plus S2O gives FeO and S2. Together they can form a deadly duo, physical pressure and chemical fire. The slag granulation pit is ground zero. Normally steam is controlled during slag quenching, but if hot metal mix with the slag, you get uncontrolled steam and hydrogen gas. The result, a pressure wave and fireball, injuries, damages and chaos. This is where vigilance must be highest. Steam causes instant pressure. Metal and slag fly at high speed. Hydrogen gas is invisible, odorless and deadly. If it accumulates and ignites, it creates a fireball with a loud blast. And then there is a belief. When trapped water erupts violently from beyond the metal surface, it's a delayed killer. Imagine this: rainwater enters on a open top ladles during transport. It mixes with the molten iron. Water gets trapped beyond the surface, and the result is dual explosion: first steam and then hydrogen. This scenario has a high injury and damage potential. It's preventable, but only if we act. Our next slide is on the data science and prevention. And here is the solution. Sensors can detect moisture, hydrogen gas, and temperature anomalies. Incident analytics helps us spot patterns. Hydrogen explosion can reach 40% higher peak pressure than steam alone. Protocols matters, and in this we must have to say that we must have to stop the movements in the rains, cover ladles, inspect water prone sites and respond to every warning, and that is the only way out. Coming to the many few case studies facing both dangers, let's learn from the history. The Port Albert disaster, steam and hydrogen combined. Open ladle incident, worldwide fireballs and secondary explosions. And the impact which it converted into injuries, cost and long recovery times. These numbers are not just statistics, they are reminders of why this knowledge must reach every furnace operator. So we can say that water, steam and hydrogen, they are silent but not visible. With science, vigilance and smart protocols, we can turn unseen threats into a better way to work, better place to work.